Hey, good afternoon, everybody. Thank you for joining us. I'm Mike Brennan. I'm the branch chief of the Hurricane Specialist Unit at the National Hurricane Center in Miami, and I'd like to welcome you to today's refresher course on National Weather Service tropical cyclone products and services for media partners. So we've got a group of speakers here today organized by the National Weather Service Tropical Cyclone Services Program to cover a few topics. If you go on to the next slide. We'll give an overview here of what we're going to present. First, we'll start off with an overview of products from the National Hurricane Center, as well as the Central Pacific Hurricane Center, and go over data access and timelines for accessing those products and the timeline for preparing and issuing them. Then we'll have an overview of the National Weather Service Weather Forecast Office Tropical Product Suite. And then finally, we'll have an overview of the NHC media pool setup and media pool access information. And then we'll wrap up with a question and answer session at the end of the event. If you go on to the next slide, we'll have an overview of our speakers today. First up, we'll have Dave Zielinski, who's the lead meteorologist at the National Hurricane Center's Technology and Science Branch, and he'll provide the overview of NHC and CPHC products and access. Next up, we'll have Tim Oram, who's the Meteorological Services Branch Chief at National Weather Service Southern Region Headquarters in Fort Worth, Texas. He's going to provide the overview of the local National Weather Service WFO Tropical Product Suite. And finally, we'll have Dennis Felkin, who's the NHC Communications and Public Affairs Officer, talking about media access and the media pool at the National Hurricane Center. So without any further ado, we'll go ahead and get started, and I'll turn it over to Dave for the first part of the presentation. Thanks, Dave.
Thanks, Mike. So like Mike said, I'm going to go over a number of the NHC products, how to access them, when to access them, and we're going to do this maybe a little differently than what you've seen before. Rather than just kind of giving you a long list of products and hoping you remember it, I'm going to try to place it within the framework of how our products are actually generated to provide some context for what's available and when, and also give you a little bit of idea of why things are available when they are. So the Tropical Cyclone Advisory Schedule occurs on a 6-hourly cadence. Full advisories are issued at 3Z, 9Z, 15, and 21 UTC. So this time of year, for those on the East Coast, it would be at 5 a.m., 11 a.m., 5 p.m., and 11 p.m. And the advisory products can be issued up to about 30 minutes before that issuance valid time. However, there are also special advisories which can be issued at any time if conditions warrant. And the most common reason for that is going to be there's a change in the initial state of the storm that requires a significant change to the forecast or to issue new coastal wind or storm surge warnings. We also have intermediate advisories, which are issued basically 3 hours after each full advisory, so 0Z, 6Z, 12, and 18 UTC. And those are issued when land watches and warnings are in effect. So there's a few different types of systems that NHC does some form of analysis or produces public products for. The first and sort of earliest stage is called the invest stage. And this can be any system with potential to become a tropical cyclone. Starting, ending, or restarting an invest is completely at the discretion of a forecaster. There's no set guidelines for when an invest may or may not be opened. And for invests, the data available is pretty basic. You just have location, intensity, and size. There may be some model data available, and those are only available on the NHC FTP. You should also be aware that it may not consistently be available for every cycle. The IDs for this, and we'll get a little bit more into what the IDs mean in just a moment, will generally be between the numbers 90 and 99 for the ATCF ID. So you'll see an ID, for instance, that looks like AL90 2021. And there's no advisory products, so there's no public products that come out of these. In comparison, tropical cyclones, which are based on their classification is based on the meteorological definition, which means they have a well-defined center, organized deep convection or thunderstorm activity, no fronts through the cyclone center, and a deep warm core. Their status, once a system is classified as a tropical cyclone, is based solely on wind speed. So the difference between a tropical depression, a tropical storm, and a hurricane is based on the intensity or the wind speed. For these systems, a full suite of advisory products is issued. And their IDs are generally between the numbers of 1 and 49. It's in a sequence for a given year. So the first system will be given ID of 1, and then we go through the end of the year. NHC and CPHC are mandated by the World Meteorological Organization to produce a forecast for all tropical cyclones anywhere in our areas of responsibility. So that means we're going to issue our products whether it's affecting land or whether it's primarily a marine concern. There are also potential tropical cyclones where the system does not yet meet the meteorological definition of a tropical cyclone. However, if it's expected to bring tropical storm or hurricane conditions, and that can mean wind or storm surge to land areas within the next 48 hours, forecasters now have the option to issue a full suite of advisory products. Because that land requirement, currently this is only considered when a system is close to land. And these systems are also given an ID the same as if they were a tropical cyclone. So let's talk a little bit about those IDs. Every system that's tracked by NHC has something we call an ATCF ID. You don't need to worry too much about what the ATCF itself is. It's software we use to help with our forecasts. But that naming convention is pretty common in the tropical cyclone community, so that's where the name comes from. And in there, there's information about the storm basin, a tracking number, and the year. So the first bit here, underlined in the red, is the basin. It's a 2-letter identifier, AL for Atlantic, EP for the Northern East Pacific, and CP for the Central Pacific for NWS basins of responsibility. Systems that cross basins from the Atlantic to the Pacific will get a new ATCF ID. However, systems that cross from the Eastern Pacific to the Central Pacific or vice versa will retain their ATCF ID. So it is possible to have an EP ID in the Central Pacific Basin. And this does typically happen a couple times each season. The next 2 numbers are the ID. So this identifying number, as I mentioned before, is chosen sequentially for tropical cyclones or potential tropical cyclones for a given year. The numbers 1 through 49 are reserved for those tropical cyclones. And thankfully we don't normally get into the 40s, but you can see this year we're already well past number 1. The next row of numbers, 50 through 79, are generally used for internal use, training, testing, and so on. So you should not really see these numbers publicly. Numbers 80 through 89 are also generally reserved for internal use, and those are used for test cases. So when we're providing training, you'll often see that we use an ID in the 80s. And then the numbers 90 through 99 are used for invests. And since there's only the 10 numbers there, we will recycle those, which means once we get to 99 for a given basin in a given year, the next one will be number 90, and we start over. Finally, the year is the last 4 digits. It's determined by the year that a system started. And if there is a New Year's storm, it will retain its ID. Now, there's another way to identify and track systems, and this is through the AWIPS and WMO headers. So there are currently in each basin, the Atlantic, Eastern Pacific, and Central Pacific, 5 storm bins that are used for the headers. So in this example here, which is the tropical cyclone discussion for the Atlantic, the number 1 through 5, which you can see highlighted in red, is used to identify which system you are looking at. All basin crossers are given a new bin to match the new basin. So these numbers are given sequentially, which means the first 5 of the year will match the ATCFID. And then once you reach storm number 6, you're going to recycle back to number 1. So typically, the 6th storm of the year will be in bin number 1 once again. One thing to look out for in the future is there is a plan to expand this to 10 bins per basin in the future. So how do products actually get to the world? All NHC and CPHC products are available on hurricanes.gov. This is a public-facing website. It's actually hosted by the NOAA Web Operations Center, and it uses Amazon Web Services. And if you're not sure what that means, you can just think of it as the cloud to manage high-demand events. So during significant landfall events, we get very high traffic on the NHC website, and that allows us to manage that traffic so that hopefully the website's working for everybody. The Hurricane Center and the Central Pacific Hurricane Center are responsible for the content, but the Web Operations Center takes care of the management of the servers themselves. We do have a backup in case it's ever needed in College Park. And it's worth noting that our FTP follows the same principle. So NHC has the ability to update content locally, and then we send that updated content to the WOC for distribution to the world. So it looks a little bit like this. Where on the left, you can see forecasters provide information to this NHC hub for updated web information. We send that to the Web Operations Center. And then what you as a public user sees is actually a series of public-facing servers. Because at any given time, you're not necessarily going to the same site. In fact, you could refresh and hit a different server in a completely different part of the country. There are occasions when the website is updating where some users have noticed that the information will appear, then disappear and be back in a moment. There's not a lot we can do about that right now. Just know that it generally is corrected within a few seconds. So there's nothing unusual happening there. It's just a factor of mirroring to so many public-facing servers, which are reflected in the cloud. Our GIS products are hosted on NWS IDP and NOAA Coast GIS systems. The URLs are here. So if you want to take a note of that, feel free. Otherwise, I'm not sure if we'll be sharing these, or you can reach out to us if you need more information. These links are also available on the NHC GIS page at hurricanes.gov/GIS. NHC sends GIS files to a central National Weather Service hub that is then used to distribute it to the different locations and create GIS services at those URLs. And it's worth noting that that process can result in up to about a 15-minute delay between when a product is issued and when the corresponding GIS data is published at other NOAA sites. It will typically update on the Hurricane Center website instantaneously. In addition to the website, text products are disseminated through the Satellite Broadcast Network and NOAA Weather Wire service, which is consistent with all National Weather Service offices. That is centrally managed by the Weather Service, so our products are going to have the same availability as any local weather forecast office. It's also worth noting that the text products will post nearly instantaneously to the NHC website. So now I want to go through a little bit of info about the timeline of the advisory preparation so you can get a feel for what products are available at what times. So as I mentioned earlier, there's a 6-hourly forecast cycle for NHC products. And you can imagine this timeline on the bottom reflecting those. So on the left, you have basically times moving as you go to the right, and you can see synoptic time when we would issue our intermediate advisories or our tropical weather outlooks, and then advisory time farther down the timeline to the right. So about 2 hours prior to synoptic time is when the advisory preparation cycle begins. And around this time, forecasters will be examining new model guidance that is arriving at the Hurricane Center. They will also begin preparing the tropical weather outlook, which again is issued at synoptic times. That goes on for about an hour. During that time, there may be other duties such as coordinating reconnaissance aircraft and so on, but in the simplified one, we'll fast forward an hour here. And new model guidance will continue to arrive at this time. About an hour before is the earliest time that forecasters can transmit the tropical weather outlook. And that graphic is drawn by the forecasters and sent to the web following the transmission of the text product. This is also about the time that the forecasters will begin working on the intermediate public advisory text products. So I wanted to talk a little bit here about the graphical tropical weather outlook. It's drawn by forecasters, and then there's images on the NHC website. You can see those right on the front page of the website. And there's also GIS files that are generated locally at NHC and available at the GIS sites I shared with you earlier or on the NHC website. One thing to keep in mind is that on the 5-day version of the Outlook, which has the drawn areas, and this is actually a GIS depiction of one of our outlooks in shapefile form. The area drawn is where genesis is expected to occur, not necessarily the full 5-day track of the disturbance. So in this particular example, this system that's farther west may be expected to form sooner, and that's why the area drawn, I should say, is much less. It doesn't necessarily mean that it's moving slower, and this may in fact only be 2 days worth of motion. So moving on the timeline here, about 30 minutes prior to synoptic time, the forecasters will be coordinating any changes to watches and warnings that will be issued with the intermediate advisory. And it's worth noting that warnings will be dropped, but never added on an intermediate advisory. This is also the earliest time that forecasters can transmit the intermediate public advisory, and the graphics corresponding to that will be generated following the transmission of the text product. And finally, this is also a common aircraft arrival time if this is the first pass of the mission through the storm. So in situations where an aircraft is just arriving, it will often be scheduled to arrive about 30 minutes prior to the synoptic time. So now we're at that synoptic analysis time. The Outlook, the intermediate public advisory have both been issued. The tropical weather outlook graphic has also been issued. And then if there were US watches and warnings in effect, the national TCV is generated and transmitted around this time as well. There will be times occasionally where that national TCV is transmitted slightly after synoptic time, depending on the complexity of any coordination going on with the local offices. So for the next 45 minutes or so, data continues to arrive to help forecasters analyze the initial state of whatever system they are looking at. Some of the data that arrives, and we don't need to get too much in detail here, you have satellite data, we may have aircraft flying through the storm. We'll be looking at any buoy data, ships of opportunity, or land-based obs for systems near land. Radar information, and we do actually sometimes even receive radio reports through ham radio. So during that analysis time and up to about an hour into the advisory cycle, the forecasters will begin to update some of the compute data that you might see. So this is the point where dynamical models are initialized. Some of our information goes into running the HWRF and HMON models, which are US models specifically for hurricane prediction. And also the GFS model will use some of the information analyzed by the forecasters to help its initialization as well. The statistical models are run models, for instance, such as SHIPS and LGEM, which you may have seen in the past. And then there's a .com file, which has some initialization information that's available on our FTP, as well as the early version of the guidance. And that early version, we don't have time to get too much into the details, but the idea is models like the HWRF and the HMON and the GFS take a long time to run. So that information that we just sent to the NWS supercomputer for the next run, those models won't be available for about 6 more hours in the case of the HWRF and HMON, and about 4 hours for the GFS. So what we actually do is we look at the previous run of those models, and we interpolate the initial position and initial intensity to match whatever the new analysis is. So you're removing that sort of short-term error and adjusting the forecast accordingly. So that early version of the guidance is often what is used to fuel the spaghetti models. And you can tell if you're looking at an early version of forecast guidance by looking for an I or a 2 at the end of the model. So for instance, for the GFS model, the GFS or GFSO is the late version of the model, which won't be available until well after the forecast is out. Whereas the GFSI is going to be the 6-hour-old GFS interpolated. And that's what the forecaster will be able to use. And that's what's going to be in the aid file that is available on the NHC FTD. For the next hour, the forecaster is preparing their forecast. Late model guidance will arrive. Some models, such as the ECMWF, take even longer to run, and therefore they arrive later. So there will be some changes to the guidance at this point. It's worth noting that files typically don't update on the NHC FTP after about 1.5 hours into the advisory cycle. And part of that's because at that point, the forecasters are basically finalizing their forecast, and any changes that come after that would be kind of too latent to change until the full advisory comes out. At this point, we're also beginning coordination of changes to any warnings with the local forecast offices. And in fact, 2 hours into the advisory cycle, we do typically do a coordination call for all systems that are threatening the land areas, particularly in the US, where we discuss proposed changes to watches and warnings, which are coordinated with local offices. And we also will coordinate our messaging, what hazards are the most imminent, and making sure that all of the offices kind of have a consistent message. Another thing to keep in mind is that we're also doing international warning coordination around the same time. So the Hurricane Center has responsibility to issue forecasts not just to benefit the US, but to benefit the countries in the Caribbean and Central America and South America as well for the Atlantic. So we are coordinating any changes to watches and warnings. We're giving the meteorological organizations in the various countries information about the forecast so that they can assist their own decision makers and in fact their own media as well. During the last hour or so of the advisory preparation cycle, the forecasters are now finalizing their products. They're composing the text products that have more free text, such as the public advisory and the forecast discussion. We're finalizing all international hazards and warning information. And then about 30 minutes prior to advisory time, forecasts can be issued at that point. It's worth noting that more complicated forecasts are less likely to be issued early and will generally be issued very close to the actual advisory. So at that advisory time, that's the deadline to issue products. Graphics are controlled by the forecaster and will generally be issued within a few minutes of the text products being sent. The national TCV is generated and transmitted around this time as well. And then P-Surge, which is used for some of our storm surge products, will begin to run around this time. So I mentioned the text products get sent first. So the text products get out to the world a couple ways. There's an internal process that will directly update the website, and that happens almost instantaneously. They're also transmitted through AWIPs like any other NWS product. So a version with the WMO header, and it's cut off in this example, but for those of you who are very familiar with our products, you'll note that sometimes on the top of the product, it will have timing information, and sometimes it has what just looks like a code. It'll often say something like ZC, ZC, and then maybe a few other numbers and letters. The internal version is going to have that code, which is used to encode the timing information for the official header. And then the official one will come back and replace that internal one on the website about a minute or so later. Now, normally, if you're looking at the website, that doesn't matter. Where you might notice a difference is if you are looking at any GIS products that have a text product embedded within it. For instance, our tropical weather outlook is an example of this. It's always going to be based on that internal version, not the one with the public WMO header. The forecast advisory and public advisory will always be transmitted before the other text products. Occasionally, the discussion will be sent several minutes later and will often be the last product issued. So the graphics and their corresponding GIS products are generated after the TCM, that is the forecast advisory, and the public advisory have been transmitted. It only takes about 1 to 2 minutes to run that, but they don't start until the forecaster initiates them. So there are times, depending on priorities of the forecaster, that the graphics will update a little later than that 1 to 2 minute time frame. The key messages graphic, since the key messages are part of the discussion, that may run relatively later if the discussion has not been transmitted yet. One other thing to be aware is that a preliminary version of the wind speed probability graphic is generated with the initial run, but that's only the 120 cumulative probability, and there's no GIS equivalent of that. The graphics and GIS products are sent directly through the website through internal processes, whereas I mentioned before, the GIS and gridded products are sent to that central hub for dissemination through other NWS GIS systems. Now, while the preliminary wind speed probability graphic is available very quickly, the final wind speed probabilities run on the NWS supercomputer about 5 minutes after advisory time, which means that by the time they finish running and then the files are generated here, the graphics and GIS products can update up to about 30 minutes after advisory time. And then one thing to note here, the potential storm surge flooding map will nearly always be the last product to update when it is available. And it's available up to 30 minutes following the completion of the P-surge run. So continuing along on our timeline here, following the advisory going out, NHC will be doing coordination with FEMA and other partners, including working any media inquiries and helping with that. I mentioned the final wind speed probabilities are available about 30 minutes following advisory time. That includes the graphics, the GIS products, and the GRIB data. Now, about an hour after the advisory goes out, P-surge will finish running. The time in which P-surge runs does depend on the complexity of the forecast, so it can be ready sooner in some cases, or in extreme cases, it could be a little later than this. And at this point, the potential storm surge flooding map generation can begin. That can take up to 30 minutes following the completion of the P-surge run. So around an hour and a half after advisory time is when that last advisory product will be issued, and that's the storm surge flooding map. So looking at what advisory products are available, for different types of advisories. This is the full suite of available advisory products as you look at it on the NHC website. So on the top, you have the text products, and then you have the graphical suite below it. All full advisories, regardless of whether they're affecting land or if they're primarily a marine concern, the text products are available for all of those systems. And then a base set of graphics will always be available. The wind speed probabilities, the arrival time of winds, the wind history, the cone graphic, the initial wind field analysis, and the track history, sometimes known as the best track or the working best track. And the GIS equivalents of those products are highlighted here. So again, for all full advisories, you're going to have information about the track and the cone, information about the wind speed probabilities, the arrival time of winds, and the best track. So this seems like a good opportunity then to talk a little bit about the cone graphic, as well as the warning information that we provide on the NHC website. So just a reminder, the cone is based on historical forecast error, and it captures 2/3 of the error for the previous 5 years. And it represents the uncertainty of where the center of the tropical cyclone might go. There's no information here about the extent of the impacts. In this particular example, there was extreme rainfall and significant flooding that occurred along parts of the mid-Atlantic that were outside of the cone. The GIS files and graphics for the cone, they include information about watches and warnings, but it's only information about coastal watches and warnings. There's no inland information. And it's also worth mentioning that the shape files, if you're using our GIS products, they only have information about wind warnings. There's nothing in there about the surge warnings. One last thing to note, the GIS files include lines between the points, but this can be misleading and is not part of the official forecast. In this particular example, again, the hurricane was expected to move a little farther north and then make a much harder right turn, but it happened between forecast hours. So this dashed line is probably a little more representative of the expected path, whereas that straight line can be a little misleading. Looking at the wind radii, so wind radii are defined as the maximum extent of winds in a given quadrant for different thresholds. There's 4 quadrants: northeast, southeast, southwest, and northwest. And in this example, you can see what we mean. So it's measured by the farthest distance from the center that winds are observed in a given quadrant. It does not mean that those winds are present everywhere in that quadrant. It just means somewhere in this example for the northeast, there are 34 knot winds occurring at that distance from the center. This means that sometimes it's going to be an overestimate of the total area of wind. In this particular example, it may be that the strongest winds are occurring in a band out here. I'm sorry, tropical storm force winds are occurring in a band due east, but to the north of the system, the extent of winds is much less. If the strongest wind in a given quadrant is less than a threshold, the value will be 0. And that might seem obvious in hindsight, but it is important to keep that in mind, especially if you're looking at our GIS products, that again, in this particular case, you can see there are hurricane force winds, 64 knots, occurring in 3 of the quadrants, but in the 4th quadrant here in the southwest, the strongest wind radii analyzed was only 50 knots. There's a smooth representation of the wind radii that's available as that's used for showing the initial sort of extent of winds on the cone graphic. And it's also available in our GIS products in the, I believe it's called initial radii. So you can see an example here. And if I go back and forth, this is actually the same example. So you can see the difference between the two. I mentioned the best track. So there are actually two forms of the best track. There's what we provide in real time, which is going to give information about the storm history, including synoptic hour positions, intensity, pressure, and wind radii, as well as the radius of maximum winds, or RMW. And that real-time file is going to update with each advisory. And you might actually notice that previous points will actually change if we get information suggesting that our analysis was perhaps a little bit off, say 6 hours ago. There's a final version of the best track that is released with each tropical cyclone report, along with a GIS counterpart. One thing to keep in mind about the best track is that it is a somewhat smooth representation of the storm history. It's not necessarily intended to be a series of instantaneous snapshots. So it will smooth through certain aspects of the storm, for instance, short-term oscillations in track or intensity, as well as reformations of the center of a storm. In this particular example, you can see the real-time analysis of Harvey had this kind of kink in it, whereas that was smoothed through in the final analysis that was published with the tropical cyclone report. In our GIS data, as well as one of our public products, there's also a wind swath that's produced. And this is produced by smoothing and connecting the wind radii from the best track, but it's not quality controlled by the forecasters. And it suffers from the same potential slight high bias that you get with the wind radii themselves. So it should really be treated as an approximation of the maximum extent of winds and not a true analysis of the total area of winds. You can see how that is constructed in the graphic here. The wind speed probabilities are generated by creating 1,000 realistic alternate scenarios that are created using historical errors and modifying the official track and intensity forecasts. It's actually computed on a fairly coarse half-degree by half-degree grid, which is then downscaled and smoothed to produce the public products that you generally are used to seeing. The grids are generated on the NWS supercomputer, and that results in the slight delay that you see. And it's worth noting that the final grids include probabilities for all storms in all basins simultaneously. So in the event that two systems are expected to affect the same location within that 120-hour period, the wind speed probabilities will account for that and show you the total potential for wind for both storms combined. The arrival time of tropical storm force winds, there's two versions of this that are available. One is the earliest reasonable, which is a 10% threshold, and the other is most likely, which is a 50% threshold. So if I go back here, you can imagine, based on these 1,000 realizations in the graphic that you see here, you could look at a given location and determine, based on the systems that cause tropical storm conditions at a given location, at what point do 10% of those members arrive? And I'm sorry, do the winds associated with 10% of those members arrive? And then 50%. And that timing information is what's used to define these earliest reasonable and most likely thresholds. Both are available as KMZ files, in addition to the graphics on the NHC website, and in GRIB format for those who want the sort of raw underlying data. REST services for these are not currently available. When US wind warnings are in effect, there's some additional text products that are issued. The US National TCV watch warning product, which has information about all wind warnings and surge warnings, including inland. And we also provide links to local office warnings and local statements. Warnings will also be issued on the cone and surface wind graphics for those cases. The main difference you will see on the GIS side is that the tracking cone shapefile will now include a warning layer, and the KMZ files will include a warning option as well. And when storm surge warnings are in effect, there are several additional products. The national TCV will include storm surge information, as will local products. And then there are 3 additional graphics that you may see. The storm surge inundation, the storm surge watch warning, and an experimental product, the peak surge graphic. And again, in those cases, there are GIS components for the potential storm surge flooding or inundation graphic and the storm surge watch warning. The peak surge graphic is currently experimental, so there is not a GIS component available for that currently. The storm surge watch warning is only available as a KML or as the interactive graphic on the NHC website. It's sent directly to the website and again to the NWS Central Hub for GIS services. There is an approximation of the endpoints included in the public advisory as well as the forecast advisory, but the KML provides more detailed information. And as I mentioned, the affected warning zones are also included in the TCV product. The inundation graphic gives a depiction of the reasonable worst case scenario of the flooding of normally dry land at particular locations due to storm surge. And this is also available as an interactive graphic on the NHC website and as a GeoTIFF, which can be downloaded in a .zip from the NHC website. There is a link on the bottom here. If you need more information about how to download and properly display the GeoTIFF information, we do have a user guide on the NHC website for that. Then finally, there's a few products that are available as needed. Tropical cyclone update statements can be issued at any time and don't necessarily follow the advisory cycle. They can be used to update information about international warnings, to update intensity or location information about a system. And if there is a hurricane with a well-defined eye within range of the US radar network, we will provide hourly updates on the position and intensity using update statements. For graphics, the key messages graphics will be available anytime that the forecasters put key messages into the forecast discussion. And then we also provide links to rainfall information from the Weather Prediction Center and a link to the Storm Prediction Center when they deem the tornado threat to be sufficiently high. Finally, for intermediate advisories, these are issued whenever there are US or international watches and warnings for land areas. The only text product that will update with an intermediate advisory is the public advisory, but a number of graphics will also update. So there's a lot of products that update at different times, and we recognize it can be kind of difficult to determine what's available. So we have a few feeds that you can use to determine what is available at any given time. And all of these update in real time along with the NHC website. So they should at any given time reflect the products available directly to the public. One is in the form of a JSON file. It updates every 2 minutes and it contains info about system IDs as well as current storm information such as location, intensity, and size. It includes links to the text products, graphics, and GIS products for the most recent advisory available. And it's important to remember that if you recall the timeline, since different products will update at different times, this means that at any given time, you may actually have multiple valid advisories for different products. So as an example, the potential storm surge flooding map may lag other products by up to 90 minutes. And the JSON will reflect that. It will say if the text products are up to advisory 27, but the potential storm surge flooding map is still based on advisory 26. That information will be here. There is a sample if you are curious to check it out on the NHC website. And then finally, we also have RSS feeds. There's information about those and a list of the available RSS feeds at this URL here. And these are basically simple XML files that point to the most recent version of text, graphical, and GIS products. And we have different versions of these. Some of them update for just a specific product. Others are intended to kind of capture everything in a given basin. And similar to the JSON file, they will all update in real time along with the NHC website. So that's what I have for the overview of NHC products. At this point, I'm going to hand it over to Tim Oram to cover some of the local office products.
Okay. Thank you, Dave. And hopefully, just give me a heads up if for some reason my slide is not showing. As Dave mentioned, I'm Tim Oram, and I'm from the Southern Region headquarters, of which we have many tropical offices. And I'll be describing the National Weather Service local office products for you, at least an overview of it here today, and representing all Weather Service offices. The map that you should be seeing on your screen right now shows the offices that issue tropical products. Not all Weather Service offices issue tropical products, just those that are most likely to be impacted. In terms of everything that Dave has described here, as you can tell, there's been a great deal of collaboration that occurs between the offices and national centers, not just the National Hurricane Center, but also with other centers like the Weather Prediction Center to assess other impacts associated with the hurricanes. So a great deal of collaboration goes on there. In terms of responsibilities, the appropriate hurricane center has the final determination on the coastal watches and warnings. And so in that case, for the Eastern Pacific, like in Southern California, as well as the Atlantic Basin, that's the National Hurricane Center. It's CPHC, the Central Pacific Hurricane Center for Honolulu. And then a little bit different out for the islands, well, in the western portion of what we call Pacific region, for Guam and Pago Pago. That's a little bit different out there. What I'm going to describe applies to probably 80 to 90% of what you're going to see. If you have detailed questions on, for example, Guam and Pago Pago, contact us afterwards and we'll get you in touch with somebody who can maybe answer those questions if you have anything there. So the local offices are the ones, other than the coastal areas, who are going to determine the inland watches and warnings, as well as the watches and warnings associated with the other hazards, flooding, for example, that I briefly mentioned. Most of our timeline is driven by the official timeline that you see from the Hurricane Center. We're looking at their products, their guidance in order to communicate our message. And we are communicating well in advance of the watches and warnings, as I'm sure most of you are familiar. We are sending out briefings and emails, posting via social media, chat, posting graphics like weather stories, and our text product, the forecast discussion, in that pre-watch phase to communicate the threat in anticipation of any potential impacts from tropical systems. As we get closer to the watch and warning phase, we may put out what's a graphic called the Hurricane Threats and Impacts. We'll talk about that here in a second. A little bit in advance of the watch and warning. And then when we hit the watch and warning phase, we issue the hurricane local statement and the watches and warnings product, the TCV, the WFO TCV product, a little bit different than the national TCV. And when in certain circumstances where we have extreme high winds, we'll issue an extreme wind warning product. And so we'll talk about some of these things here as we go forward. I wanted to talk a little bit about the local office tropical webpage because it's probably the easiest access point to access all of our various products and resources for you. It's linked obviously from the local office web pages in general. And then as Dave mentioned, when a storm is potentially impacting an office, the Hurricane Center and CPHC will also link to the local office page. I'm showing, hopefully you can read all of these little tabs on the top of our page. A couple of them only appear when there are active storms present. One called the Active Storms tab, which takes you to National Hurricane Center or CPHC products. And the other is the Local Products tab. That will only appear when there are active storms present. We did try and work very hard across all our offices to have a very consistent look and feel on this web page to allow you easier access to find information. You don't have to guess, where to find information if you're looking at Philadelphia versus Houston. It should be very similar. And also, if the office is issuing a local briefing, it's usually going to be linked at the top of the web page to provide you easy access to that as well. Just a couple things to mention on here. The preparedness tab has some very useful information. It's customized by our offices, and it can include things like local evacuation zone information from emergency managers, generic information ahead of a storm that people can use to determine, their likelihood for having to be evacuated, etc., as well as other links that they may add there. So there's some local information that you may find valuable from the offices in those two tabs. The social media tab provides quick access to our Twitter and Facebook accounts from every office. We do have Facebook Live, which is currently experimental at several offices and is being proposed to expand, as well as Instagram, which is now experimental at 28 offices. And as I said, the Tropical web page can give you quick access to either of those. In terms of Facebook Live, generally what we advise to our offices is that's great in that kind of pre-watch phase, but things get very busy in an office as we get closer to the watches and warnings and the actual impact. And so really our use there is more in providing general outlook information. And we're looking to the media, to do the wall-to-wall coverage, if you will. That's not really our role. And that's our general guidance to offices, just so you can understand how we're trying to use live streaming. Many of you should be familiar with NWS Chat. It's an instant messaging program that we use to share information. That information is shared within a limited community, our core partners, as we define them, and that includes the media and emergency managers. For those of you who aren't on Chat, you're not missing out necessarily on any information. The only information that's really released there is basically publicly available information, and we respond to questions from the media or the emergency managers throughout an event. One thing we do recommend is the use of a real chat client, in quotes, something like Pigeon, and mobile applications like Boogie Chat and Talkanaut. The image that you see on the right-hand side is a picture of what's called NWS Chat Live, just to give you a feel for that. But in general, what we found is that Pigeon and the mobile apps are a little bit quicker and more resilient when we get into a heavy workload situation with chat. Diving into the local office products here a little bit more. As I mentioned, there's a difference. We have two TCV products. There's the National TCV, and then there's the WFO Weather Forecast Office Tropical Cyclone Local Watch Warning product. And that is our official watch warning product for dissemination. And we'll take a look at that here in a second. In terms of the timeline of when you're going to see things issued, Dave talked about the advisory cycle that the Hurricane Center and CPHC go through. We need the national public product before we can issue our local watches and warnings. We grab certain information from there, as well as information from other data that is coming into the office before we can issue our TCV product. And that'll go out. Our goal is generally to have it about 15 minutes after the advisory time, hopefully before that if we have everything in place. So you will see a little bit of a lag between the National Center products and what the offices are going to start issuing. I put the TCV first because that's our first product that is going to be issued. And then the Hurricane Local Statement, which provides an overview of the detailed information that's in the TCV, is then issued by the office. And so the TCV has to be issued first before the offices can issue the Hurricane Local Statement. We'll talk a little bit about the hurricane threats and impacts, but that's basically a graphical depiction of the relative magnitude of the various hazards that are associated with any tropical event, the wind, surge, flooding, as well as tornado threats. It is required to be issued in order to issue the TCV, but sometimes offices will want to try to start using that to communicate the local threats, and they can do that up to about 72 hours prior to the onset of tropical storm force winds, or about 24 hours before we would anticipate issuing a TCV or an HLS. And then, as mentioned, the extreme wind warning is really a short duration warning advising people of the most extreme winds associated with the strongest storms. So diving a little bit into the TCV product, which is the official watch and warning, some important parts here, and I'm showing just an abbreviated version of it, and some of the key portions of what you'll see in that text product that gets issued. It is a one segment for each weather service forecast zone. And so it can be a very long product. Often, if you were to print it out, it could be 20 or 30 pages in length, depending on the number of zones that are affected by a particular storm. But it's extremely important. It contains not only the zone information, showing an individual zone here, but the coding, the valid time event coding that is needed to trigger NOAA weather radio, the emergency alert system, and wireless emergency alerts. And so this is what drives a lot of those notifications that people will see on their cell phones. In addition, we'll have headlines, and then for each zone, it will have a segment for each of the hazards that we talked about: wind, surge if it's a coastal zone, flooding, and tornadoes. And then each section has basically three things within it: the deterministic forecast, what we are basically expecting, what you would look at in the wind case, what you would see in our wind grids. But we also have a section for each one that talks about what you should prepare for. And that is to encourage people to plan for those conditions, as opposed to what might just be coming out from a deterministic forecast of our winds. And then describing for people the impacts associated from those potential winds. As I said, that's repeated. The first one here is the wind, shown the wind segment, and then the flooding, rain, and that repeats for the other segments that we talked about. As I said, it could be an extremely long product. It was originally designed as something to be used for decoding and splitting up, to be used in automated systems. But what we realize, given the detail in it, a lot of people will actually go in and read it for their particular section of the forecast area that the office is issuing for. If you want to see the difference between Fort Lauderdale, for example, and Miami, the TCV product is where you can get perhaps the differences in the potential impacts and the potential to prepare for winds. The hurricane local statement, as I said, is more of the overview from the local perspective, but it has some very good information in it. It has a section with the new information, any changes to the watches and warnings, storm information from the local perspective, and so the distances will be relative to points within the office warning area, as opposed to maybe some national points. The situation overview is the forecaster's description to you of the situation from the office perspective. And then it also has potential impacts, again, summarized from the TCV for each of those four hazards that we talked about. And I've only shown the flooding, rain, and the wind here. Now, the order of the potential impacts in the hurricane local statement is set by the forecaster to communicate the first hazard, the most threatening hazard first. In this case, they chose flooding, rain, and then followed by the wind. So that's one way of communicating to people the relative impacts that we expect at the local level from any particular storm. The hurricane threats and impacts, as I mentioned, are a graphical depiction. It's available as a KML that can be downloaded from the webpage, as well as a downloaded image. Only the KML is a composite of all the hurricane threats and impacts graphics issued by each of the offices. And so what I'm showing you here is from Claudette. a summary of each of the 4 hazards across all the various forecast offices who are issuing the HTI at that time. And so there's one for the wind threat, one for the storm surge threat, one for the flooding rain threat, and then one for the tornado threat. And again, this is built around what we want to communicate people to prepare for. This is not the deterministic forecast. And so try to conduct your actions around the potential threat and take precautions based upon that. The extreme wind warning, as mentioned, is reserved for events that are catastrophic in nature, a very significant threat of casualties. We picked an example here from Hurricane Michael a couple years ago. It will only be issued first if it's being identified as a Category 3 or higher hurricane. And then the second criteria is that we have to observe winds of 115 miles per hour coming onshore. And so it's going to be issued if it's imminent onset or the continuation of winds greater than 115 miles per hour to communicate primarily to people the most impacted areas from these extreme storms. It is generally a short-term product and valid for 3 hours or less, and it will alert via the wireless emergency alerts. And so I've shown you what might be posted through social media, via Twitter, the graphic associated with that, the hurricane radar at the time, as well as the text product that's associated with it. And finally, before I transition on over to Dennis, I just wanted to talk a little bit about interviews and media requests. For local media, work with your warning coordination meteorologist ahead of time. Discuss if they have any unique best practices or procedures that they like to follow at their office for media requests during tropical events. Hopefully you're involved in the integrated warning team meetings that offices are having, where you get together with emergency managers and you can discuss ahead of time a lot of these what if type scenarios for not only tropical systems, but also tornadoes, et cetera. I know the national media like to talk with the local offices in many cases. We pulled an image from our San Juan office on their Twitter feed. And the NHC pool can be your starting point for media requests. In contacting the office, if their workload is too great, you may be directed to somebody else to talk about the media requests that you might have, and they can answer any questions. So they may be located at another office, at a weather service region, weather service headquarters, or just a volunteer that we've activated for this particular event. But rest assured, they are informed about what is going on and can answer your questions. And finally, we do have a limited number of employees who are proficient in Spanish and could do Spanish media interviews. And we activate what we call the Multimedia Assistance in Spanish team to help with that. And they also support Dennis Felkin down at the Hurricane Center as well for media interviews in Spanish. If you want to reach out to me, if you have any questions, you can use my personal email address, and also the tropical webpage email address shown here actually will reach several of our tropical experts. And so it's not limited necessarily to just tropical web questions if you have any questions there. And so what I will do is hand this on over to Dennis at this point. To talk a little bit more about the about media.
All right. Thank you, Tim. And hopefully everybody can see this screen. If not, let me know. I'm Dennis Felkin. I'm the Communications and Public Affairs Officer here at NHC in Miami. I can't believe it, but I'm in my 15th year here and I'm closing in on 20 with NOAA. One of the many hats I wear here is for you folks. I'm the liaison between the Hurricane Center and especially our media partners. So we've got a lot of media partners. It's print, it's radio, and TV. And everybody all wants it at the same time. So we offer media opportunities both inside and outside of the hurricane season. And there's a variety of ways to do that. Right now with the pandemic, it's pretty much all virtual. On-site interviews are kind of clamped down, and hopefully next year we'll be able to resume actual on-site interviews. But there's the National Hurricane Conference. There's the Hurricane Awareness Tour, where we take the NOAA Hurricane Hunter plane on the road at 5 locations along either the Gulf Coast or the East Coast. There's the Governor's Hurricane Conference. And of course, there's our annual media day. And these are just to name a few. We've got different formats and settings for it. As I said, on location, you can get them via satellite. We can get them virtually. Phoners, of course, are still done, particularly for radio and print. There's our annual media day. And of course, press conferences for really big events, which are very common on our media day. So during the hurricane season, it gets a little more difficult because our specialists are on shift work, 8-hour shift works, 8 to 10 hours shifts, 24/7. And so their availability to the media is a little bit different because their job is watching the tropics. So any of those things, of course, like outside the season, inside the season, they've got to be arranged through me as the public affairs officer. And we'll record them or have virtual interviews, but on an availability basis only. No live shots though, and you can't hang around the media room to edit and write your stories. You're going to have to go back to your station or into the truck to do that. So what we have is a media pool. Rather than having this whole frenzy here, we have a pool camera set up. And anybody in television knows a pool camera, what that is. It's one camera which will feed out the video and audio interview to a particular station, or it can go out to everybody. It's in full operation when we have a hurricane watch or warning issued for any portion of the US mainland. We give live interviews for the networks and the local stations that are in the watch or warning area. So if you're a local station and you're not in the watch or warning area, we're not going to be able to facilitate an interview for you. And we do a lot of them. Last year, we had more than 450 interviews provided, and that was a record for us. Of course, it was a record season. We have several different pools here. We have the English Language Network pool, which is ABC, CBS, Fox, NBC, CNN, and in the last 3 years, AccuWeather, Weather Nation has joined us in addition to Weather Channel. So that's 8 networks that are part of the pool. We have the local English language pool. So there's our local Miami affiliates, English language. And we have a combination of the local and network Spanish language, and that's primarily Telemundo and Univision and Telemundo Net and Univision Net. So all of those are different pools. We also have what's called a soft or limited media pool. Now there's no watch or warning out, but in days 3 or 4, you're looking at the cone going, uh-oh. So we'll do that. We'll open a limited pool. We'll do it from 7 in the morning to 9:30 in the morning to catch the morning newscast, particularly in the networks. And then in the afternoon prime time, late afternoon, early evening prime time from 5 p.m. to 6:30 p.m. The broadcast and cable networks and the local stations in the potential threat area will be the ones who will be given the feed. Here's how the pool works. You get that email advisory from me and you're looking and go, yeah, I want to be taking part of this. You book an interview time with the producer. You can do that via email or via phone. Then once you've booked your time slot, you contact your network for the pool feed. There's no charge for this. You contact your network for the pool feed, and then when your time's ready, you'll be ready to go. We do offer at the top of each hour a generic broadcast, so anybody can take this. It's not aimed at one particular station or one particular city. It's a generic feed. It's at 30 seconds past the top of the hour. It can go up to about 3.5 minutes in length, and again, it's obtained via the NHC media pool line through your network. We also make an audio recording of that generic feed, and we make that available. It's a digital feed. It's available about 7 minutes past the hour. A lot of the radio and print outlets use this, and it's linked under top news of the day, or we've got it at nhc.noaa.gov/audio. So when the pool is open, we've got the generic feeds going, there's an audio broadcast. Now the priority, as I said, is to the local stations. And we found some challenges, even in the way we've upgraded it here. The pool, for whatever reason, seems to be underutilized by local stations. And I think a lot of that is because they didn't know the availability of it. But what I also found out within the last year or two is some of the networks are actually charging their own local affiliates for use of the lines. I've heard of fees of $100 to $200 for a 10-minute window. I personally think this is absolutely absurd and makes no sense. So that's something you would probably need to go to your network and say, look, this is kind of important. Why are you charging us? So that's something, unfortunately, some of the local affiliates have had to deal with. So we also do Facebook Live. Tim Oram mentioned that earlier. We'll typically do that 30 minutes past the hour after each advisory. So we'd be looking at, we'd start at about 8:30 in the morning, another one 11:30, then at 2:30, and at 5:30, all of those Eastern times. They can last up to 8 minutes, and we've been asked in the past, and absolutely, yes, you can send those out on your own website. You can live stream them. The more audience we can get on that, the better. And these are non-scripted, just we just tell you what's going on using the different graphics. So where to call if you've got anything related to the tropics? Call the Hurricane Center Public Affairs Office. There's the email address, there's the phone number,